this is the, anybody can understand version, okay? In linguistics, there's 4 levels. Statistics, syntax, semantics, and pragmatics. Okay? Now you can find this in any linguistics book. Okay? Statistics is the alphabet, and E occurs more often than Q. You find this in Shannon's book, by the way. Okay? So, letters. Syntax is spelling and grammar. Syntax is, this word means this. Syntax is, you went to the, you go to the store is a statement. Did you go to the store is a question.
That's under syntax.
Right, that's syntax, okay? Semantics is what is meant, and pragmatics is what is intended.
What's the result that's intended?
Right. There's a desired result, okay? So communication on the sending end starts with a desired result. It goes pragmatic, syntax, semantics, syntax, statistics, and then when the person listening, it goes the other way, okay? Then you have, in engineering, you have this idea called the OSI 7-layer model, which basically looks like this. At the top, you have something called the application layer, which in your computer is like Microsoft Word, okay? At the bottom, you have something called the physical layer, which is copper wire or fiber optic cable. And then you have these other layers in between. The second layer is the actual ones and zeros, okay? And so, once again, we start at the top, we encode a message, we send it across, we decode it. And it's always in this order, okay? Now,
evolution ties to this?
Yeah, evolution has everything to do with this.
Okay.
Because what is really happening, if you think about it, what real life, real world communication systems actually look like is this. Encoder, 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 decoder, 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 decoder.
And that's all the layers, you mean?
Yeah.
Yeah, gotcha. Yeah.
Which I just drew, right?
Right, you just drew them.
It's like words, Microsoft Word, email, internet, all the layers inside the internet packets, okay? These layers have to be encoded one at a time and decoded one at a time, and they have to be done in the proper order.
Yeah.
Okay? I can't put my Matryoshka doll together in the wrong order. Okay? So here's what Darwinian evolution says. Darwinian evolution says, after I've encoded, 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 and encoded, then I can mess with this and improve it. And then when I open my Microsoft Word document, I'm going to have an improved message from you. Okay, anybody who understands computer programming understands that is completely absurd.
Even the worst idea doesn't get better.
Right.
When it gets nested
Right.
at that level.
If you take an internet packet and mess with it, what you get is a computer that can't read the internet packet, an email that will not open, a Microsoft Word document that won't open, and if you could open it, if it was just corrupted enough that the computer could do all this stuff, when you did open your Microsoft Word document, it would be garbage. And most people have had the experience of somebody sends them a file and they open it and it's all garbage. Like, could you resend that? Yeah. Right? Yeah. So here's the thing. A layer has to be changed at its own level of encoding. The only place that I can edit a Microsoft Word document is in Microsoft Word. You can't edit a Microsoft Word document when it's embedded in a string of ones and zeros here. I realize I just jumped.
You jumped.
I jumped from computers to DNA without really probably connecting the dots. So fire away.
So go back to computers for a minute.
Right.
Because in this example, my idea that gets incorporated into words, into Microsoft Word or whatever, if I change my idea, you can detect that something has changed at this level.
Of course you can.
There is a detectable change here.
Right.
And it's straightforward. It's not random.
Right.
You know,
Right.
but there's different orders of bits now.
Right.
So there is a relationship from here to here.
Right.
Isn't it possible that noise could introduce at this level such that my idea gets improved?
A non-engineer could probably be convinced that that's true. I say try it.
And the reasons why not? I mean, because it is something to do with probability?
Well, first of all, try it at any level.
Okay.
Okay, let's say we're just talking about Microsoft Word. Let's take your document and let's randomly change letters.
Yeah.
Try it. I made a website called randommutation.com where you can try this. Mm-hmm. You stick anything in there in the little box you want and click mutate and see if you can ever get it to be better that way. Mm-hmm. Now in Shannon's lingo, you are modifying it at the statistical level, and the claim is made that it improves the pragmatics, or it improves the semantics.
Shannon's lingo for evolution.
Well, in Shannon's lingo for the layers of communication.
Yeah.
Okay, because DNA has these layers too,
Right.
and I'll get to that. But just in the computer world, what when you modify this, you're modifying at the statistical level, where what you wanted was an improvement at the semantical level. Okay, so you write me a Word document, and can random changes to your text make it have better spelling? Maybe there's a very tiny chance they can improve the spelling. It's extremely small. Can they improve your grammar? Can they improve your Can they improve the structure of your sentences? Can they make your message more persuasive or more effective? Try it. Mm-hmm. Just try it and see where it gets you.
I think when you say try it, it's okay to hold on to that idea, but then go test it and then let common sense
and observation
right. take over,
right.
and then realize,
right.
Okay, this is harder than it may seem.
Let's test the
probabilities
hypothesis.
are very difficult.
Right.
Okay.
In other words, Darwinian evolution is a testable hypothesis in the computer world. Mm-hmm. Well, what you'll find is if you have a computer program and you want to make it better, the worst thing you can do is randomly mutate the code. Now, even in the computer programming world, you have source code and you have compiled code.